Okay, so what, again, always recap within the first minute. What stuff did we do over the last couple of days? What's the first thing though? Oh, position. And from it, we created what? Displacement in how many dimensions? One and two with the car problem yesterday. So today we do what? We do distance. Who would like to define distance for us without looking at this? Like, let's say, for example, your younger sibling asks you, what exactly, like, we hear displacement and distance. What is distance? When you think of distance, what jumps to mind? When you think of distance, don't use scientific words. Just make it simple. Yeah. And everything will be related that way. But how about thinking of distance on its own without having to relate it to things like that? Sure. Yep. Perfect. So what? One way to understand distance is what? How far is what? 1 point from. So basically, what I like to call physical separation in what? In space, mostly 3D space. What's another way to think of distance? Let's say you take a walk. How do you know your and you come back home? How do you know your distance at the end of it? What do you just do? Count. So count and then do what with all the steps? Addition. Thank you. Add up all the motions you've done. Those are the only two ways to understand distance. If you're not moving, it's just between 2 points. If you're moving, like my Fitbit or whatever, it's just counting up the steps and adding them up. Perfect. Okay. So it's not really perfectly done in the textbook, so I did not even provide, or maybe it's done like in a couple of lines. No, I want to go deeper. So aside from displacement, another physical quantity can be extremely useful. It happens to be also the most famous of the two. Can be extremely useful when an object undergoes some motion. This quantity is called distance. Okay, so there are two ways to define it depending on the situation. One of them is what I contributed is the physical separation between two fixed or not moving points in space. And technically, the points have to be what? Distinct. What does distinct mean? Anyone? What does the word distinct mean? Come on. What's the word distinct? What does that distinct mean in English? What does? Yes. Thank you. Yep. Different. Not the same. They have a certain feature that is not the same between the two of them. Okay. By the way, what's the if 2 points are not distinct, what are they essentially? Thank you. So the distance is what? Yeah, the distance between something and itself is zero. Perfect. All right. The other way is if something is moving. Okay. The total or sum of all the motions that are physically traveled. Okay. Those are the only two ways to define distance, depending if there is motion or if there is. We're gonna be using both ways because we will run through different situations. Okay. So I have a question for everyone. What is the distance? Because that's gonna go into the next slide. Yes. What's the distance? And you don't have to give me the correct answer. What's the distance from London to Toronto? 200. Thank you, ish. So let's just go with what? 200 kilometers. How about the distance from Toronto to London? And it's not a trick question. 200 kilometers. So does it matter if I say from to in this particular situation? Okay. So does it matter which direction you go? So we just said that the distance from Toronto to London is how much? 200. And we said that the distance from London to Toronto is. So we just established that all that matters is we're going from, between what and what? So did direction matter? What just mattered? Thank you. Do you think distance is a vector? You just said that direction doesn't matter, which means what? Is distance a vector or a non-vector? What is the name for non-vectors? Anyone knows? Scalar. Thank you. A scalar is just a fancy way of saying what? A number. A scalar is just a fancy way of saying a number. So now this is our first example into what? Into non-vectors. Okay. So the physical symbol. Now, everyone? What was the symbol for displacement from yesterday? Not just D. Delta D with the what? What was the meaning of the arrow? We're dealing with what? No, the arrow, the arrow. We're dealing with a vector. But now we're dealing with a what? Which means, do I use an arrow? No. Using an arrow in a scalar notation is a mistake. You can just say, I'll just show it to him. He can just scratch it if he doesn't want to see it. No. That tells me you do not understand what scalars, and you think that everything is basically the same and I can just take the symbols for whatever I want. No. If something is a scalar, you can never show an arrow sign. Boom. That's it. That's how easy it is to actually remember distance. It is the exact same symbol as displacement, although it has no vector nature because there is no point of giving me a direction for distance. Okay? So the absence of the letter arrow above the symbol indicates that this particular symbol, physical quantity, is a scalar. You will learn a lot about scalars and vectors and how they could be combined in very specific ways with Mr. Shivers in grade 12 calculus and vectors. Vectors, even though the name is called calculus and vectors, when you study vectors, you also study what? Because there's so many insane applications of vectors and scalars together. Half of physics is based on the application of vectors and scalars together. Okay? Okay, so in other words, distance is just a what? Okay, now hold on for a second. Just so you know, I mean, it is just a number. But this is, everyone, this is an important comment here. Some physical quantities in nature are not just numbers. They have to be what kind of numbers? Can you ever get a negative distance? What do you think? Can you ever tell me, again, how many meanings did we take for distance? Two. Either the what? The separation between 2 points in space, or the what? Or the sum of all the motions traveled by an object. Okay, so let's think about this. Can you ever measure the distance in space between any two objects and produce a negative number? Does it ever make sense to say, oh, the distance between me and Yasmin, for example, is negative 3.5 meters? Makes no sense. So that means what? Distance has to be what kind of a number? Okay, same thing. If I travel, whether I come back to the same point or not, does it make sense to say I traveled negative 3 meters? But does it make sense to say I traveled negative 3 meters west? What did we do yesterday? Did we sometimes run into negative vectors? That was fine because I could always do what? Flip it, direction, and get what? Get myself what kind of a vector now? A positively magnitude vector. Make sense? So vectors could be what? Negative, but you can always what? Distance though can never be what? No, can never be flipped, which means it's by default what? Positive 24/7. Are there some physical quantities that are both scalar and potentially negative? Can you think of one? Thank you. Outside temperature. Although, by the way, we're going to talk about this in more detail when we talk about energy. Temperature in a couple of months, temperature is going to be what outside? Negative 20 or something. Okay. Is there really anything negative? By the way, what does temperature mean? If something has a high temperature, what does that do? So what's happening to the particles inside? Are they're what? They have a high vibration or a high what? A high moving frequency. How about if the temperature goes down? Slow down and vibrate less and less and less. But even when the temperature is negative 20 outside, is there anything negative about the motion of a particle? No. So why do we call it negative? Negative just means what? It's below what? It's below zero. We decided that there's a certain temperature or a certain vibrational strength that we call what? 0 degrees Celsius. Anything above it is what? Hot or positive. Anything below it is what? There's nothing negative about the universe. Negative means what? According to a certain reference we invented, it is what? It is what? Below it, right? If you do an XY axis and someone says, put a point at -2, is really anything negative about this point? No, it just happens to be on the what? On the left side of where we said the center of the universe. Is it making sense? Make sure you understand there's nothing negative in the universe. It's negative as far as the reference that you decide on. Perfect. Okay, so just a number. But I want you to add here, my bad. I want you to add what? How many people have seen this way of writing the word? What's this word? Anyone can guess what this? This is a shorthand, very famous in math and physics. Nope. Okay, I thought someone said. I thought this. I'm not kidding. This is the way that we write the word positive in math lingo. I'm not kidding. I am not kidding. At least I'm preparing you for that. Remember, math is a legit language. It's like coding. What's up? Oh, okay. No. It's just because negative is what? Negative VE. It's because it's the last two letters of the word. Seriously. Positive, you just write plus. See, you can't just write plus because plus is not positive. Plus is the what? Is the symbol for addition. Positive is the what? Is the actual word for positivity. Trust me. You're always gonna say. So get used to it from now on. Positive is just plus VE. What's negative? Negative VE. Okay. Get used to the shorthand notation. All right. All right. What's the mathematical formula for distance? You know, we start with symbol and then mathematical formula and then probably unit and so on. There's the way that we do things. Here's the good news about what's up. You go ahead. I'm sorry, what? No, no. Oh, but you know what? We definitely will have time today to cover speed and velocity, and you will see the relation. Here's the good news about everyone about distance. There is really no equation. And the reason is why, okay, think about it. What was the first definition of distance? Come on. What was the first definition of distance? The separation between 2 points in space. Did we do something like that yesterday? Did we do a separation between 2 points in space yesterday? Did we do a 2D dimensional distance yesterday? Yes, we did. How did we find out the length of that tilted dashed line? What did we use? We used the Pythagorean theorem. So geometry could help us with what? With the first definition. How about the second definition of distance? It's the what? So who needs a formula for sum? Just add up everything. You see what I mean? So there's no set equation. It depends on the situation. The good news is you're either adding things up or using trigonometry and geometry to find the length of the distance. All right? Good. What do you think the physical unit is? Come on. We're still in distance and length, which means we are still standard meters. Thank you. Perfect. Lowercase m. Okay, everyone, pencils down. Because this needs to sink in. Because again, by the way, I act out a lot of things that you will definitely see that, oh my God, he practically answered this true, false, or multiple choice question that we have now on the quiz. Okay? All right. Which direction did you say? Did we say that we're always going to assume this way? North. Okay. All right. So, okay. Which way am I facing? All right. What is my displacement in steps? Huh? Displacement. I need a vector. 3 steps. Thank you. You need 3 things. You need the number, you need the unit, and you need the direction. Okay. What distance did I travel? 3 steps. What? Hold on. I told you you don't need direction for distance. See, I tricked you. What do you just say? No, you just in steps. You just say what? 3 steps. By the way, I'll prove to you why it's completely illogical and wrong to have a direction with distance. Okay. Okay. So far, what is my displacement? 5 steps. What is my distance? 5 steps. So far, right? What's my distance now? Distance. The sum of all the motions I've done. How much? 7, right? Because I walked 5 and then still piled up another what? Another 2. But what's my distance? Interesting. Okay, hold on. Do you remember what we did yesterday with this? Do you remember the first method we did when I asked you for the overall displacement? Do you remember what we did for the overall? What did we do the long way? What was it? What did we just do? No, that was the short way. I want the long way. We added delta D1 plus delta D2. You remember? So in a way, I could do that here. Delta D1 plus delta d2 plus what? Delta d3. Okay. What was my first motion? How many steps? So 3, and let's not say steps. 3 in which direction? Plus. Then what did I do? Then what did I do? Actually, I did 2. 2 steps which way? How can I deal with this? Obviously. And you can tell. What are these two going to do to each other? Cancel out each other, which makes sense. These two are going to negate when you do what? So what's your overall displacement? Is this sinking in now? So what's my displacement now? 3. What's my distance? Okay. How much did I even go further north? No, just this part. North. What happens now? Cancel, 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 cancel. So what's my displacement? 0 steps. Technically, you have to say what? Now, here's the weird thing. You have to give me a direction. But it's weird. You traveled as much what? As much. So does it matter really what you say? It doesn't, but it still matters to give me a what? Thank you. A vector, even the 0 vector still needs a what? Even though it has no size. Remember this, the thing we said, the debate yesterday? Some people say it has every direction it could, or it has no direction. No, it has any direction you want. Okay? But what's my total distance now? 3, 2, 2, 3. So what do you conclude? Whenever you start moving, does your distance ever go down? No way. Because what happens to distance as you keep moving? It keeps what? It keeps what piling up on itself. What could happen to displacement though? It could potentially what? Eat from itself. By the way, you do not even have to reverse to give you that idea. Okay, here's another example. By the way, and this leads to a very important result in math and physics. What's my displacement? E steps out. What's my distance? 3 steps. Okay. What's my distance? Distance. 5 steps. And use that's it. 5 steps. What's my displacement? Yeah, you're right. Good. They're not opposite. In fact, they're not one-dimensional. They're what? How do we do a two-dimensional yesterday? I just sketched a triangle. Do you see now? You see why sometimes it's actually easier to do the 2D than the 1D? Because the 2D, you're always going to imagine what? A triangle. In grade 12, we do a lot of what? Scalene, not scalene, non-right triangle, like oblique triangle. So my question now is, my distance is how much? 5, non-negotiable, 5 steps. How am I going to know my displacement from my initial to my final? What do I do? Pythagorean. All right. Here's my triangle. No, not trigonometry. If I want the angle, though, I just want the length. Because there's something I want to tell you about the length. How much is this? How much is this? How can I find this guy? Square, blah, blah, all that. So what's the final answer? 9 plus 4, which is what? Can someone guess the square root of 13? It's got between, okay, 13 is between what and what good square numbers? It's between 9 and 16, right? Which means the square root has to be between the square root of 9 and the square root of what? What's this? So between 3 and 4. So you know what? We know it's somewhere between 3 and 4, right? Let's say 3. Does it have to be exactly 3.5? Nope. Let's just say 3.4 steps. My point is, what was my distance? What's my displacement? It seems, well, with an angle, whatever I work out. My point is, which one is always bigger? Once you start moving, no matter how you move, one line, 2, 3, which one always is bigger than the other? Why? Because distance never what? Goes down. It's always what? How about displacement? You could cancel yourself, or you could what? By the way, oh yeah, I mentioned that this leads to a very important result in math. It's called the what? It's called the triangle. It's called the triangle inequality. A triangle could have a side longer than each of the other two, but never longer than what? No, never longer than both of the other two. Do you see what I mean? You can never, I don't care what triangle you sketch. Doesn't even have to be a right triangle. Even this triangle. Is this one longer than this? No, just by looking. Is this one longer than this? Is this one longer than this? Is it longer than both of them combined? No way. This universe is built that what? A triangle never has one side longer than what? Both the others. The only way, you know what? I'll prove it to you. Here's the easiest way to do it. What do I have here? What do I have here? Rulers. Okay, everyone. That's the third side, right? By the way, what do you call a triangle that is identical in only two sides? Isosceles, okay? So is this one longer than these two? No. Is it now? But if I add, by the way, what's the addition of these two? No. The addition of these two sides. 30 plus 30 is what? There is no way this is 60. And we can do it, we can prove it using the what? The sine cosine law, because this is not a right angle. Those two addition are still what? 60. Is this still 60 yet? But is it getting closer? When is it going to be exactly 60? But then you don't have a what? You got it. You see the ideas? That's how you check. So whenever you do a physics problem, and your displacement came out to be bigger than your distance, what do? You erase that right away, otherwise I'm going to kick you out. Okay? Can distance ever lose to displacement? Displacement can. By the way, when is the only case that displacement and distance are always the same? If I never change my what? If I don't reverse, if I don't curve, if everything is on the same what? Same direction, not just same line, exactly same direction. Then everything what just keeps piling up. Once you start deviating, it eats up from itself. Nice. So here are the what? The three major differences between these two. Number one, go ahead. Displacement must have direction. Must have direction. Not could or may, must, which means if you don't give me a direction for displacement, you lose half a mark of your final answer statement. Not therefore statement, just a final answer statement. Distance not only does not need a direction or may not, no, must have no direction. If I ever read that the distance traveled is, 3 meters south, I have to take a mark off. This is an example of a case where providing more information that you need is actually what's going to backfire. Okay? By the way, I'll prove to you that why distance does not need, listen up, does not need a, a direction. Question, everyone. How many steps? Which way? How many steps? 4. Which way? To you. No? What? To you. West. How many steps? 3. Which way? How many steps? 4. Which way? To you. East. What's my displacement, by the way? I came back to the identical first location. What's my distance, though? Again, I'm exercising. I want to know how far I went. 3, 4, 3, 4. How much? 3 plus 4 plus 3 plus 4. Like 55? You destroyed the math and you destroyed the English language. 14. If someone says 14 meters and then you pause and you're like, north. I'm like, why? You walked in how many directions? Why are you favoring one over the other 3? Do you see my point? And if you're saying, okay, you might say, I'm going to take the longer one. You still have 2 identical longer ones that are going what? So why would you choose west and not what? Do you see why distance cannot have a direction? Because it completely goes against what? The fact that you just want to pile up how much motion you did. Awesome. Because displacement relates what? Relates where you were and where you ended. Distance just, Do you remember what kind of observers? Hold on. Passive and active. Who's the active? The what? The distance person. The one who never what? Looks away. The one who's always keeping tabs on you. Who's the passive one? The displacement. You turn, and then you're like, Mr. Ramadan, done. I look, I find you exactly in the same spot. So to me, you what? You did not move. But to you, did you move? Yes, because you are active observer. Is it making sense now? One is watching all the time. One is content with where and when, regardless of what of the intermediate step. Like what? Oh yeah. Okay. By the way, just so you know, everyone, is east also right? What do you think? If I'm facing like this, and we say this is north, can I say this is east or right? Yeah. Can I say this is west or left? Can I say this is north or up? You have any idea how many people think that north and up are the same and south and down are the same? Are north and up are the same? No. North is a geographical direction. Up is a what? Physical direction. Same with what? South and maybe on a map, yes, but in physical reality, not. So obviously, yes, there are so many ways to what indicate direction, especially with angles, but those are just the easy ones I'm just using. Make sense? Yeah. But again, but always remember, south and down are not the same thing, except on a 2D map in front of you. Yeah, the great, exactly. So many ways. Just make sure you differentiate what physical direction from what geographical plane direction. Yes. All right, another symbol. There you go. Yasmin, that's my answer to your question. Displacement only what? Cares only about going what? Because I didn't what? I didn't watch. I passively assess the situation. So I assumed that you directly went from start to finish, regardless of the actual path, because I can't make an infinite number of guesses. I didn't see it. What am I gonna guess? Every possible which way you did? Nope. I'm gonna assume a beeline from start to end. Distance, though, is different. You have to go through the trouble of watching along the actual physical path from start to finish. Okay, so that's the second important distinction. The third, and I believe last important distinction, is you know what? They're either equal, or if one of them is gonna win, it's definitely gonna be what? Distance for sure. Distance never goes down. That's why, by the way, I always had an issue with some calculus textbooks. Again, how many people are hoping to take calculus and vectors? Okay. I am not saying that the ones who authored it don't know anything, because obviously they are teachers and profs sometimes. But I do have an issue with one thing. What is the yes? I do have an issue sometimes. Everyone, look. We're gonna do this a lot next week, like maybe over 2 days. We will do something called kinematic graphs. Kinematic graphs, like relating time to distance or so on. I never agreed with this. Look. What does small t stand for? Always in physics? Yeah. They give you, the teacher says, or the book says, here's a distance time graph or a distance time profile. And then, look, what's going on here? No, 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 no. Forget speed. This relates what? And time. At the beginning, distance was going what? Oh, sorry, not going up, increasing. And then what happened? Can distance ever decrease? We just said the more you move, the more what? The more you pile up, the more you accrue distance. What could this one be? Thank you. Displacement. Or what? Maybe even what? Maybe even what? Yeah. A vector could what? Reverse. A scalar never reverses. Okay? That's a comment I always made whenever I would talk to a calculus teacher. I'm like, I never understood that because that goes against the definition of what. Okay? That's it. That's all we need to know about what distance and displacement theoretically. Okay? Okay. It is. Okay. Here's the thing. Distance is such a very short concept related to displacement, it's not worth it to do an example just for that. So now we're going to cover speed and velocity, and then we're going to do a big example that combines everything. Because a true physics problem should really be multiple concepts. Okay. Oh, here's another example. Everyone, look at this. Okay. Let's say that you have an air track and you have an object on it. Everyone, did it move? So what do we have for sure? Do we have displacement or distance? It moved. I saw it. It piled up some traveling in space. Houston, we got distance. Go ahead, just write that down. How can you prove to me that it did not have displacement, or I should say overall displacement? Apparently, it went back from the same di to the same. Sorry, from di to the same df. Guess what? You go back to the same position. You have 0 or no displacement. Go for it. Okay, that's the last slide you have for this one. If anyone is wondering what's this Houston thing, this is the way that they used to actually call the Apollo 11 and Apollo 13 missions. Apollo Houston, we have a problem. Houston, we have a problem. Houston is basically NASA center where they actually launched the rocket. Okay. All right. Next one. Nope. Okay. Now to the more. All right. I'm just going to give you this. This one is 2 pages. No, I'll give you 2 pages. All right. Everyone's good? Okay. Okay. So okay. Question, everyone. What is the only physical quantity in the universe that you cannot control? Time. Can you ever control time? No, you can. It's not time itself that you control. It's your sensation of time that you control. In grade 12, we were taught, hopefully I tried to make it to such that the last week of the course, we delve a little bit into like quantum mechanics and modern physics and relativity, as even as little as we can. We talk about effects that basically take effect or take place when what? Listen up, everyone. When you can only travel at speeds comparable to the speed of what? Speed of light. Thank you. Things do not feel different to you. Things feel different and look different and are actually different to people measuring you from the outside. Why? Because you're very what? Insanely fast. And again, by the way, just so you know, these effects really only take place at speeds that, by the way, what's the speed of light again in vacuum? Anyone remembers from the unit conversion sheet? 300,000 kilometers in one what? In one single second. Okay. By the way, there's another way to think about it. If light could bend, by the way, could light ever bend on its own? Nope. You have a laser pointer. You point it. It's going to be exactly one straight line. Light could only bend in one of 2 ways, either through a mirror or lens or basically some kind of a refraction or reflection medium, or if it passes near a very massive, dense object, like what? Black hole. Thank you. Exactly. So my point here is, if light could travel around the Earth, like around the equator, it can on its own. But if it could, at a speed of 300,000 kilometers per second, in 1 second, it could traverse or circle the equator of the Earth, which is the biggest circumference, 7.5 times in 1 second. That's how fast it is. You can calculate the circumference of the Earth because it's approximately a perfect sphere. I know the radius of the Earth, 6,400 kilometers. You can calculate the circumference and divide 300,000 by it. It will be 7.5 times. That's how fast light is. My point is, Cars outside, what's the maximum speed it could get to? Like a sports car. I think one time I actually looked it up, like 7 years ago, it was like a Bugatti Veyron or something like that. It was like 300,000 kilometers per second. What's the fastest plane? By the way, do you know how we measure faster than sound speed? It's called Mach. Mach 1, Mach speed, Mach 1, Mach 2. I think so far the fastest they produce is Mach 16. Something that could go 16. It's unmanned, by the way. It 16 times the speed of sound around it. It so far it's an experimental aircraft. It's operated as a drone because a human cannot take that much acceleration to build up to it. We're gonna talk a lot about acceleration. They all say in car accidents, it's not speed that kills you. No, you can go as fast as you can. It's the sudden change in speed when you brake or when you hit something that kills you. Speed is okay. You can build up to as much speed as you want, no problem. Just make sure that when you stop, you don't stop what? Exactly. You take your time slowing down, okay? Because of the force principle. Okay, so my point here is Mach 16. Maybe then you can what? You can notice the effects of what? Of time dilation. Your time is not the same time measured on the plane and so on. Okay, but my point is you can never control time. You control what? Your sensation or feeling of time. But even to do that, you need to go to what speeds? High speeds. So basically, it's almost near impossible for a human to experience what time exactly those effects. But my point is, time passes. You cannot control it. It's the only thing you cannot what control. Which means what? You can always relate everything to what? To time. Anything could be related to time. Anything. When displacement is related to time, a new quantity is created. That's what we call what? That's what we call velocity. Okay? So the definition of velocity, it describes, or sorry, one way to understand it, it describes how rapidly, how rapidly the position of an object changes as time passes by. Okay? How rapidly. Go ahead. So how rapidly the position of an object changes as time passes by. It's the, I know this is not a word, but just to, kind of like approximate the meaning, it's the quickness or how fast of the straight line displacement from beginning or from start to end. Okay, I'm going to provide you with one last way of thinking of velocity. And anyone who will do calculus, actually not just even calculus, no, you will start even talking about slightly, even in grade 11 functions, you will talk about it so much in advanced functions, and it will be the only thing you talk about in calculus. Something called rate of change. Rate, remember when I talked about rate? What's rate? Rate, again? So it's related to delta. Rate of change is basically what? How fast something is changing. Is this a high rate of change or a slow rate of change? So rate of change is related to time. I am making more water flow per second. That's it. Okay? Can someone guess the physical symbol for velocity? And it's exactly what you're thinking of. Exactly. It is V. All right? So the uppercase or lowercase though? Yes, because we said yesterday that uppercase could stand for what? Volume or electricity? Voltage. Thank you. All right. Okay. Let's go to the next slide. We just said that velocity is described in terms of what? And it's a vector. So that means velocity itself is a what? How easy is it to remember that velocity is a vector? It begins with a V. Thank you. Velocity is a vector. Hey, it's all about mnemonics, right? Just find a way to remember things. So the physical symbol for it then it's not just a V. It's a V with a what? System always works. There we go. Must have a direction. Okay. What's the equation for velocity? We just said that velocity happens when you relate what to what. Look at the second slide. When you relate displacement to what? To time. By the way, this distance is gonna come later. Hold on, just give me a few minutes. Oh, sorry. Okay, everyone, let's talk about this. Everyone, there are two types of velocity. So actually, okay, everyone, listen up. When you relate anything to time, you can always produce two types of that thing. Okay, depending on how short of a time are we talking about. Okay. The good news is we're not gonna deal with both types in grade 11 and 12. We're only gonna deal with one. Why? Calculus is needed to deal with the other one. The one we're not gonna deal with is what? Instantaneous velocity. What does an instant mean? What's an instant, by the way? Okay, here's another question. How short is an instant? How short? Again? 0.1, so a tenth of a second. Trust me, you can go shorter than that. I love bro. So, who knows the names? Who knows the names of small scale? Nano, milli, micro, nano. Can you go lower? Oh yeah, you can go lower. Does anyone know what's lower than nano? By the way, nano is a billion. So a nanosecond, everyone, how short is a nanosecond? It's a billionth of a second. So imagine this time, everyone. Imagine this much time. That was just what? 1 second. Divide that into a billion parts. One part of those billion parts is a nanosecond. How about if you go 3 times as small? Or sorry, like 3 magnitudes of 1,000. Pico, which is 1 trillionth of a second. Guess what? There's a femtosecond, which is what? 1,000 trillionth of a second. The femto actually got very famous in the late 90s because one Egyptian American physical chemist at Caltech, California Institute of Technology, won the Nobel Prize in chemistry because he invented the shortest. How many people do photography here or understand the meaning of the term shutter speed? What's the shutter speed? What's the shutter speed? If you take a picture with any camera. Thank you. It's the what? It's the shutter of the what? Of the camera. It depends. It's basically what tells, as Ibrahim said, how much light you allow in. You allow too much light in, very what? Very bright. You allow very little light in, very what? Very dim, very dark. You just need to allow the right amount of light in. Well, guess what? That Egyptian chemist, he passed away like 3 or 4 years ago. His name is Ahmed Zuwail. He invented a camera that had a shutter speed of a femtosecond. Here's the thing. It's called a camera. It's really not. It's his lab called Femtoland at California Institute of Technology, Caltech. It's a laser beam that could vibrate at a frequency of what? Of a femtosecond. Do you see what I mean? Can you clap your how fast can you clap your hand? How many claps do you think I can do in a second? 10 maybe? Laser can vibrate at 1,000 trillion claps in one single second. So the question now is, what kind of pictures did he need such a shutter speed for? He needed to what? Capture nuclear reactions. Nuclear reactions happen very what? By the way, if a car goes in front of you and you take a picture, is it clear? It's blurry because it's very what? You need your shutter speed to be so fast to actually just what? Capture that just nanoseconds instead of so much of the car going through. Chemical reactions happen at the order of what? Nanoseconds, picoseconds. So you need a camera that basically what? It's so fast. His camera was a laser beam here, a laser beam here, a laser beam here, a laser beam here, all concentrated right here on a small vial where a chemical or nuclear reaction is happening. And the way that the energy is bouncing off the molecules and registers, that was exactly the same, the right amount of light or energy that was needed to actually capture that one, measure that reaction. And he won the Nobel. Say again? So not a picture, a modeling simulation, but as accurate as the electrons are hopping from one molecule to the other. That's basically it. And he won the Nobel Prize in 1999. And he was the father of femtochemistry. Femto because it's happening that fast. Okay? So my point is, how fast is an instant or how short? You can make it as short as you want. Which means what? You can always go what? You can always go shorter and smaller and smaller. Well, guess what? Newton invented calculus to deal with what? Very very small instances of time. That's why we cannot do this one. All right? What's the symbol for it though? V inst. By the way, what is instantaneous velocity? It's your velocity when you're driving, and then your friend asks you, how fast are you going? And you look down at the speedometer or the odometer, whatever your eye registers that second and your brain gets, that's your what? That's your what? That's your instantaneous velocity, which is technically the speed at which you what? You get caught when what? When you have the radar gun on the highway. They never cloak you on what? On an average speed. They cloak you on what? On the what? On how fast you were going when you passed in front of the what? The radar gun. Okay, they tell you when you passed by me, you were going at what? At like 150 kilometers per hour. By the way, again, he did not measure you exactly an instant. He measured you maybe over a millisecond or a what? Or a nanosecond. But to us, a millisecond is as close as to what? As an instant as it could. Do you see what I mean? By the way, can you ever detect something happening over a millisecond? No. Our sensations probably don't go beyond 10% of a second, maybe, or something. Like, for example, if I have the lights right now, and the light flickers over a millisecond, we're not gonna feel it. Why? Our sensation is not as what precise. You see what I mean? But if it flickers over a tenth of a second, do you think we're gonna kind of feel it? Yeah, tenth of a second. Yeah, we can feel that. All right. Okay. So this is the one we're gonna do. Average velocity. What's average velocity? It's your velocity. How many people have heard this word before? What's this word? Interval. Where did you hear interval before? I'm pretty sure you never heard it in a physics course, but you definitely heard it in a what? Math course. What's an interval? How many people have heard of a number line? What's a number line? The x-axis in a way, right? What's the interval? It's basically some chunk of that what? Some chunk of that number line. Like an interval is from x equal -3 to x equals 7. Like this, for example. Everyone, this is an interval. This is an interval. This is an interval. This is an interval. A chunk is an interval. Okay? So average velocity is the velocity over an interval or a period of time. Like what? I don't know. Like a second, like half a second, like a nanosecond, technically, like a minute, like a day, like a year, whatever. What's the symbol for average velocity? VAV. By the way, I've seen it. Listen up, everyone. I've seen it AV. I've seen some books AVG. Okay? We're just going to call it AV. Okay? We are only going to do average velocity for the entire course of grade 11 and 12. I cannot teach you instantaneous velocity. I cannot teach you the methods of analyzing it because it requires what? Calculus. Thank you. Yes. Which means if you do first year physics, oh, you're going to be doing both because you've already covered this one and you already are coming in with what? With calculus knowledge to analyze instantaneous velocity. Okay? Requires calculus. That face. It's not required calculus. Thumbs up. Okay? We're going to do just that. Okay. Okay. What's the mathematical formula for velocity? So, yes, it's equal to what over what? Displacement divided by time. Can someone tell me what the equation will be like in mathematical notation? What's the symbol for average velocity? I just showed it to you the slide before. V with an arrow, AV. What's the symbol for displacement? Delta D. If it were position, fine. But what's the display? What's the symbol for time? True. But everyone, we're almost never going to use just lowercase t. We're also going to use what? Because think about it. T itself is what? Is like an instant in time. We're doing what? An average. So we're doing an interval. An interval needs a what? A beginning and a what? So it needs an initial time and a final time. That's why technically you never deal with an instant. You never deal with a single t. You always deal with a delta t, delta t, delta t. Okay? This is the equation for what? For velocity related to displacement and time. By the way, is this the only way you can write this equation? Can you rewrite it or rearrange it? How? How can you rearrange anything that has a fraction in it? There's a word before multiplication. Cross multiplication. Thank you. How can you crisscross this? You have to have a what under this? 1. And now you can come up with another equation. Delta D times 1 equals what? Equals what? Velocity times time. That's exactly what math teachers like. They don't like cross multiplying. They like to cancel out, like we did in the. You know what? And that's why I never teach it that way. Cross multiplying to me is the quick and dirty way of doing it, and it works every time. Why? Again, math teachers want to always teach you things that relate to fractions. I get it, but if there's a quick way, just do it. Trust me, I am on your side 24/7 in public. I used to memorize these things. Okay. All right. What's the physical unit for the velocity? It's the physical unit for what? Displacement divided by the physical unit for what? What's the physical unit for displacement? Meters. What's the physical unit for time? Not days, not minutes, not hours, seconds. So what's the official standard unit for velocity? It's what? Meters per second, which obviously you have permission to write either this way or this way. Obviously, why do you have two ways? Well, my intention here or my preference is if you're ever doing unit conversion, it's good to keep it in pure legit fraction form. If you're expressing a final answer, you don't need to make it a fraction. You can make it the slash or the per final answer form. Okay? All right. Now let's go to the twin of velocity, which is what? Speed. A more common, I guess, more famous, more familiar one. Okay? Distance is is almost like what? Displacement. So it's delta. Delta D, but without the what? Because no direction is permitted, not just needed. Okay, everyone, let's go to speed. How many people are familiar with speed? You hear it more than you hear velocity. So what's the definition of speed? What was the definition of, what was velocity? It was what related to time? Displacement. So what do you think speed is? Instead of relating displacement to time, you relate distance to time. You got it. So whenever distance is related to time, a new physical quantity called speed is defined. Sorry, my bad. In simplest terms, speed describes how rapidly, not the direct going from start to end changes, no, how rapidly the object is moving along the actual path taken as time passes by. Remember, distance is the active observer, you looking every time, like the whole time of the motion. Displacement is the passive observer. You just care where you started, where you ended. You could not care less what happened in the middle between those two instances. Okay? Do you think this? Sorry. Do you think speed is a vector or a scalar? And you have to argue why you say either. So, Sally, why do you say scalar? Interesting. Distance and time are both what? How can you combine two scalars, which is just two what? Two positive numbers, and somehow produce a what? A vector with a direction? That makes no. If nothing could produce a direction, nothing ever will get bigger direction at the end. Okay. So, what was the symbol for velocity? Lowercase v with a what? Okay. So, what do you think the symbol for speed is? Yeah. Here's the thing. I know it. No, no. I've seen books with S, but most of the time, it's actually yeah. So it's kind of like displacement and distance. All you do is you just remove the what? Remove the what? You just remove the arrow because you are not vector anymore. You're purely scalar. Oh, really? How many people don't have the third sheet? The one with speed. Oh, you have the. Oh, sorry, sorry. There you go. So all we do is what? Just remove the what? But we still know speed is a what? Vector or scalar. How can you always remember that? No, because of S. S, S. Remember, no, that's how I remember it. Velocity is a vector. Speed is a scalar. It just happens to have the same symbol as what? As velocity. Again, I did not make the rule. Yes. You just got it. Exactly. All symbol wise, all you do is you just remove the error. That's it. You cannot give me a direction for speed. Have you ever got or have you ever heard? Listen up. Have you ever heard of a velocity ticket? No. What do you get on the highway? A speeding ticket. You don't get a what? Have you ever been stopped and saying, you know how fast you're going and in which direction? No one ever says that. You just ask what? Do you know how fast you're going? We know the direction. We just want the magnitude of the what? Of the motion. That's what speed is. Okay? How many types of speed are there? What and what? Instantaneous, whatever you see on the speedometer, and which is the one we're going to deal with. So it's exactly the same. So instantaneous speed, which is your scalar speed at an instant or a moment in time, when you suddenly look at your car speedometer, whatever your brain remembers, at that moment, that's your instantaneous speed. And it's VNs, which requires calculus. Average speed, which is the speed over an interval, which is exactly what they do at what races and competitions and all of that. No one measures how fast you. But okay, actually no, that's not accurate. They do measure instantaneous velocity. You know when? When someone like Usain Bolt crosses the finish line. By the way, do you know how they actually measure instantaneous speeds at these events? They have a laser beam that basically what bounces off of him, or basically like a laser gate. When he crosses it, it measures the what? It measures his speed of him cutting the circuit, and that tells you exactly how much speed he closed through the finish line. But we know that his speed, average speed. By the way, he still holds the record for what speed? Sorry, for what race? 100-meter dash. 100 meters. His speed. Sorry, not his speed. His time so far 9 seconds 58. Sorry, 9.58. So slightly over 9.5 seconds. Okay. Can we find out how fast he's going? If you know the distance and the time, can you know how fast you're going? It's the same equation as the displacement. Just take the arrows out. Okay? So let me show you what I mean. Okay, so let me just go to the next slide. I'll upload these at lunch. Don't worry. Ta-da! Average speed is how much distance you were able to travel in total, divided by how much time it took you to travel that distance in total. Bless you. How many people have seen this before? This triangle. Yes, you see it in, actually, you see it in math courses a lot. Sadly, math teachers, just show it and don't explain really what it means. This is a powerful triangle. You know why? Everyone, check this out. Whenever you want to calculate something, what do you just do? Look, hide it with your hand. If you want distance, look, hide distance. So what are you going to do with V and T? Yeah, they're on the same level, so you multiply. You want speed, what do? Hide it. So what remains? Divide distance by, thank you, which is exactly the equation. If you want time, what do? You divide what? How far you traveled by how fast you were traveling to see how long it took you to travel. Perfect. So here's my question to you, everyone. Pencils down. Who's got a calculator on them right now? You do? Okay. What's the distance that Usain Bolt got? What's the standard distance for his race? Come on. No, we need to discuss this because this is important. It's got 100 meters, solid 100 meters from beginning to end. What did I say his time was? So far, I think to Wikipedia and the records, it's 9.58. Interesting. So what do I know about Usain Bolt? I know the what? And I know, uh, go ahead, divide 100 by 9.58. Obviously, it's slightly more than 10. 10 point what? 10.4 in what unit? Meters per. Yeah, it makes sense. Meters per second. Okay, everyone, pencils down. Someone says, okay, so Usain Bolt, instantaneous speed was always 10.4 meters per second. Does that make sense? Does it make sense that his speed was always 10.4? Okay, what's the easiest reason that this makes complete nonsense? What if he was a machine? Second, okay, question. The race, when they start a race, do they run and then start the race, or do they start? So what's the initial speed? And thank you. So that means what? They need time to what? To build up, and then maybe what? Main. Do you see what I mean? So that means definitely his speed starts from what? And then he built up to maybe, by the way, does that mean he built up to 10.4, whatever number we have, and kept it the whole time? Is there a guarantee that he was going at that exact speed the whole time? Probably, but on average, was most of the race done at that speed? Now you get the idea. Instantaneous, right there. Average, but we know maybe it took him a second to what? To accelerate. And by the way, have you ever compared, and this is real, have you compared the physiques of 100-meter dashers and marathon runners? Who's more jacked? The physique, the body of a 100-meter dasher and a marathon. By the way, how long is a marathon? 26 miles. Half a marathon is 13. 26 miles, the Boston Marathon, all of that, 26, which is about 42 kilometers. Compare the bodies of the two. Why? Do you need a what? You have only how much distance to prove yourself? 100 meters. How much distance does the other person have? 26 freaking miles. 42,420 times that much. Which means what? Who needs more explosive power? The 100 meters. And that's why, look, seriously, look at their leg training. It's insane. They explode, accelerate from like 0 to 60 or like a car in what? Like 1 second maybe, and then just what? Keep gunning it for the remaining 8.5 seconds. Is it making sense now? That's between instantaneous and average. All right. Physical unit is identical because units don't have direction. A meter is a meter. Who cares if you go right or left, up or down, left at 30 degrees? A meter is a meter. You can spin a meter stick and it's still a meter every time. Okay, so this is the exact same slide as the physical unit for the what? For the displacement.